Hello everyone. Today we're going to 2.4 average rate of change of functions. Here of functions. Okay. So in the beginning, I'm going to talk about the net change. It's like a review from previous slides. I mean, from previous classes. So the net change. Here I can say the net change of a function of x between x equal a and x equal b is, so what is the net change? Who can remind me between these 2 points? If I have 2 points, x equal a and x equal b, what is the net change between these 2 points? Anyone can remind me what is the net change here? B minus a. Is it b minus a or f of b minus a?
F of B minus A.
Anta. Exactly. It is f of a, f of b minus a. So the net change here can say net change equal f of the second point b minus f of a. Now, after we learned the net change from the previous class, today we're going over the average rate of change. So the average rate of change is depending of the net change. So here I can say the average rate of change is of the function of the previous or of the function and the above. I mean this function of x between these 2 points. So the average rate of the function and the above is equal. So I can define the average rate of change as here average change, average rate of change equal the net change is equal the net change between these 2 points the net change over two things, over what? Over b minus a. The net change between this is equal and this is equal actually. The net change here is f of b minus f of a. So I can say here this is equal f of b minus f of a over f of b minus f of a over b minus a. b minus a. Okay, any question for the average rate of change? This is the formula. This is important formula. You should to memorize this formula. The average rate of change is equal the net change over b minus a. The net change between these 2 points is f of b minus f of a over b minus a. So there is a relation between the net change and the average rate of change. There is a relation or connection between the net change, the rate of change, and the average rate of change. Okay. Also, I should to know the average rate of change is the slope, but it's not the slope for the function, because sometimes the function is a parabola. It does not have a slope. The slope is only for the linear function. The slope is only for linear function. But the average rate of change is also the slope of the secant line that passing the point on the graph of the function f. So I can say here the average rate of change is the slope of the secant line between the points on the graph of the function f. It's similar to the formula of the slope, y2 minus y1 over x2 minus x1. It's similar to the formula of the slope. But the average rate of change is the slope of the secant of between 2 points on the graph of the function. Now so there is some example about the the average rate of change. So example here. So my example, let I have a function f of x. Suppose I have f of x equal 3x minus 5. This is my function. F of x equal 3x minus 5. The question is, find the average rate of change of the function f between the following points. So for number one, suppose my point between x equal, for example, 0, comma, x equal 1. This is the first one. Second one, suppose my for part 2, x equal 3 and x equal, comma, x equal 7. Number 3, between the point x equal a, comma, x equal a plus h. Who will do the first one? Who will find the net of change, the average rate of change for the first one?
So it's going to be f of 1 minus f of 0.
Number one, the average rate of change equal f of 1 minus f of 0 over what?
Over 1 minus 0.
1 minus 0. This is correct. Over 1 minus 0. Now plug the 1 inside the function. What I get?
-2.
-2. Like 3 times 1 is 3, minus 5 is -2. Minus f of 0. Plug the 0 inside the function here.
Would be
-5.
-5.
-5, because 3 times 0 is 0, minus 5 is -5. Over what? Over 1.
Over 1.
And anything over 1 is like when the 1 is in the denominator, it's like we can remove it, right?
Yeah.
We can remove the 1. We don't have to write it over 1. So -2 minus 5 is
Equals
-2
3.
plus 5 equal 3. This is correct. -2 plus 5 over 1, or I can write it as -2 plus 5. And -2 plus 5 is 3. Now for the second part, number 2. Between x equal 3 and x equal 7. So here, number 2, I should know the function f of x is equal 3x minus 5, and the points are x equal 3 and x equal 7. X equal 3, comma, x equal 7. Okay, who will do this one? Number 2, the average rate.
Good.
Yes, go ahead.
So we would do 3 times 7 minus 5 and then 3 times 3 minus 5.
Again, it's f of what?
Oh, it's f of b minus f of a.
F of b minus f of a. What is b here?
7.
7, okay. Minus what? F of
F of 3
3 over what?
over 7 minus 3.
Minus 3, okay. Now, what is f of 3, f of 7? After you plug the 7 inside the function, plug the 7 inside this function here.
It's 16.
7 times 16, because 7 times 3 is 21 minus 5 is 16, correct? Minus, what is f of 3 when you plug inside the function?
It would be 9 minus 5,
It's
which
4.
is 4.
Exactly, 3 times 3 is 9, 9 minus 5 is 4. Over 7 minus 3 is?
It's 4.
4. Okay. Now, 16 minus 4 is?
12 over 4.
12 over 4. And 12 over 4 is?
3.
3. Okay, perfect, correct. So for the second one, the average rate of change is 3. Now for the third one. Third one is the same function of x, this one, of x equal 3x minus 5. And the points are x equal what? X equal a, and x equal a plus h. A and x equal a plus h. Okay, who does this one? Who will do
I'll
this
do it.
one? Okay, go ahead.
So it's f of a minus f
F of
of,
a or f of a plus h?
oh yeah, f of a plus h
Okay,
minus f of a
f of a over what?
over a plus h minus a.
A plus h minus a. And what does that equal?
Is it f of a plus f of h?
Yeah, f of a plus h. Here, plug it this one inside the function.
Oh,
Yeah.
It's 3a
3a
plus 3
plus,
plus 3h,
okay,
and is it minus 5?
minus 5. Okay,
And then
minus
minus 3a
3a
minus 5
minus 5. Correct. Over what? A plus h
over
minus
h.
h, exactly. Okay, now we have to distribute the minus inside the second parentheses. And we should remove this parentheses. Okay, so this is equal here 3a plus 3h, 3a plus 3h minus 5. Now distribute the minus inside the parentheses. This here and this here. So I'm gonna get here minus 3a plus 5 over h. Now we can, in this question here, we can simplify it more and more. We can simplify it more and more. So look, 3a minus 3a, they cancel out. We have here a minus 5 and 5. We cancel out. Now what I get? I get this one, 3h over h. 3h over what? Over h. And what is the answer? Exactly. It is 3 equal 3. So my question now, why, like in all step in number 2, they give me 3. Number 3, they give me the same answer, the average rate of change 3. And for number 1, they give me the same answer 3. And all the points is different. Like look, the number 1, x between 0 and x equal 1. For the second part, x equal 3 and x equal 7. And for the third part, x equal a and x equal a plus h. So in all this, number 1, number 2, number 3, the x value are different, but it's giving the same average rate of change. For the first one, they give me 3. The second one, they give me 3. And also for the third one, they give me the same things, 3. Why the average rate of change is the same here?
That would
Here,
mean that all those points are part of the same line. Maybe.
but all this, can you repeat what you said?
I guess that would mean that, for example, you see all like x equals 0, x equals 1. All of those points, would that mean that all of those points are part of the same
Okay.
line or the same function? I guess.
The same function, but but this is not exactly the answer, because if I change, for example, the function here, if I change the function, they will give me different answer. They will not give me 3, 3, and 3. But why for this exactly, for this function or this here, give me the same answer? Here, Muhammad said the average rate of change equal the slope. This is correct, but can you like explain more? You're close to the answer here. If I change this function, for example, 3x squared, and I use this point, I'm 100% sure for number 1 and number 2 and number 3, they will give different answer. But for this function, they give the same answer. Why? Because they are intervals? No. Like points from the line? This is not the answer. The answer is because this function is a linear function. For the linear function, if I see the function is linear, the mean of linear, the variable raised to the power 1, if the function is linear, they will give the same average rate of change when you change the value for x. Even if you put 100 for the first x and you put for the second x 200, they will give the same answer, 3. Why? Because the function here f of x is a linear function. But if I change the function to any function, like for example, parabola x squared, they will give different answer. But because the function here f of x equals 3x minus 5 is a linear, they give me the same answer. My question now, what is the slope of this function? What's the slope of this function? Is it 3?
3x? Yeah.
Is it 3 without the x? Is it 3?
Yeah, 3.
So look, yeah, because so for the function, linear function, the slope is the same as the average rate of change. Even if the points are different, the average rate of change will be constant or fixed, the same answer for all part of the question for the linear function. And the average rate of change is the same as the slope is 3. See the 3 here is the slope. The average rate of change is the same as the slope. So here I can say the average rate of change is constant for the linear function have constant average rate of change, and it is the slope of the function. Okay, this is what you should know for this section. Now, let's go to the next section. It is 2.5, the linear function. So here's 2.5. The linear function and models. So in this section, we're going to learn more about the linear function. Since we talked about linear function before, but we're going to go over and give more details about the linear function. First of all, we have to know what is the mean of linear function. Can anyone remind me or give me the definition of linear function and what is the mean of linear function? What is the mean of linear function? Constant rate of change. Yes, but can you define what is the mean of linear function? How is the function look like? X has a power of 1, virtual as a line. This is correct. Function has a variable x, and this x raised to the power 1. Has one independent variable and one dependent variable. This is correct. It has independent and dependent variable. It has one independent variable, and sometimes it has two independent, but actually it has the independent variable here in this function raised to the power 1. This is the important things. What else do you know about linear functions?
You could say if the function actually, yeah, never mind. I was gonna say something different.
Yeah, it's fine.
No, I noticed I was wrong.
Okay. What do you know? What do you know also about linear function? How is the function look like? How can I define it here?
A straight line.
A straight line, but what is the formula for the function?
Y equals
It's a
mx plus
function.
b.
Again, the
Y
form
equals mx plus b.
y equals mx plus b. This is correct. This is for line, but I'm going to define the linear function. This is for the line, but for the linear function, I can define it as f of x equal, like she said, mx plus b. This is correct, but here I can change the m as ax plus b. The a here is the slope. And what is b? Can you remind me what is b?
The y-intercept.
Exactly, the y-intercept. Thank you. So the graph here of a linear function is a line with slope is a. This is my slope. Can define it as m or a. So my slope is a, and the y-intercept is this point, is b. So it's a function of the form here, of the form of x equal ax plus b. The graph of a linear function is a line with the slope is a, with the slope a, and the y-intercept is b. And y-intercept is b. Correct. Okay, first of all, I'm going to give example how we can determine if the following function is a linear or is not a linear. So example 1, we have to decide or choose, determine if the following functions are linear or not. So number 1, f of x equal 2 plus 3x. Number 2, g of x equal 3 times 1 minus 2x. And number 3, h of x equal x times 4 minus 4 plus 3x. And the last one is number 4 is k of x equal 1 minus 5x over what? Over 4. Here over 4. Make some space. One minus 5x. And here is 4. Okay, for the first one, is it the first one is a linear function? Is it of the form f of x equal ax plus b?
Yes.
Yes. Can you rewrite this one as of the form f of x equal ax plus b?
It would be
yes,
f of x equals 3x plus 2.
exactly, 3x plus 2. So it's look like the same as these things here. The a here is 3, the b is 2. So it is a linear function. Here I can say yes, correct. For the second one, is it a linear function? Yes or no? Yes. Anta said yes. Can you rewrite this one as of the form of x equal ax plus b?
Yes, it's gonna be g of
Yes.
x equals negative 6x plus 3.
Exactly. Negative 6x plus 3. This is correct. So here the A is -6 and the B is 3. So for the second one, yes, correct. For the third one, is it a linear function? H of x equal x times this thing here inside the parentheses? No, but y is not a linear function. Why this thing is not a linear function? Can you rewrite it? Can you distribute the x inside the parentheses?
It would be 4x plus 3x
4x, 4x plus
3x squared.
3x squared. And here we have square root. We have exponent is 2. What does that mean? Is it a linear? No, it's not a linear. This is not a linear because we have variable raised to the power 2. And this is a quadratic, yes. For number 4, is it a linear function? This one here? And I said yes. Can you explain why? Can I write it of the form this? Why is yes?
Yes, it is because if you divide, you will still get a fraction, and the slope will be -5x over 4.
-5 over
X,
4x.
yes.
Okay. And what about the one?
minus 1 over 4.
Plus.
Yeah, plus 1 over 4.
Plus.
Yes, yes, plus 1 over 4.
Yes. This is correct. So for the fourth one is yes, correct. This is a linear. For this one, we can distribute the 4 for the first term and for the second term. So this is equal 1 over 4 minus 5 over 4x. And then we have to, you can rewrite it of the form ax plus b. So you get minus 5 over 4x plus 1 over 4. Any question for this one? Okay, example number 2. So the example here, number 2 for the linear function. Let f be a linear function by the f of x equal, I have the function f of x equal 3x plus 2. Number 1, make a table of values and sketch a graph. Number 2, what is the slope of the graph of f? So my function f of x equal 3x plus 2. This is my function, and we have to do the first one and second one. Okay, who do the first one? I'm going to do the first one together because we have to make a table, small table. Here's the table. Make a table, so we need the x value, and we need the f of x, and we need the order pairs, x and f of x. So here is x, here's f of x, 3x plus 2, and here we have x comma f of x. So we're going to choose random points. One, two, three, 4, 5, 6.
Ajá. ¿Y qué pasó con eso?
Okay, for x, I'm going to choose the point negative and positive. So I'm going to use -2, -1, and 0, and 1, 2, 3. 1, 2, 3. What is the value when I plug the 0? What's f of x here?
2.
0 times 3 is 0 plus 2 is 2, correct. So the point here is 0, comma 2. What about the 1?
5.
5, correct, because 3 times 1 is 3 plus 2 is 5. So the point is 1 and 5. What about 2 here?
8.
6 plus 2 is 8, yes. So the point is 2 and 8. And the last one, 3, 9
11.
plus 2, 11. So 3 and 11. For the minus 1 is
-1.
-1, because 3 times -1 is -3 plus 1 plus 2 is -1, yes. So -1, comma -1. What about the -2? 6 plus 2 minus 6 plus 2,
-4.
-4. Exactly. So the point is -2 and -4. So now we're going to graph the Cartesian plane. Here is the Cartesian. Here is the point. 1, 2, 3, 4, 5, -1, -2, and the point here is 2, 4, 6, 8, 10, -2, -4. Here 12. 2, 4, 6, 8, 10, 12. Here we have 1, 2, 3, 4, 5, -1, -2. Here I have -2, -4. So the first point is 0 and 2. So here's the 0. So here is 0 and 2. 0 here and 2. This is the first point. Here, this one. Second point is 1 and 5. Here is 1. This is the 1 here. And the 5 is here. Between the 4 and 6. Third point is 2 and 8. Here is 2. And here is 8. So the point would be here. And I have 3 and 11. Here is 3. And here is 11. So it's look like a line, as you see. Now at the minus, -1 and -1, this is -1 here. And here is the -1 and -1. So the graph of the line look like this. Actually, the -1 and -1 is around here at this point. -2, sorry, -1 and -1 is not here, it's down. So this is -1. This is the point -1, and the -1 between the 0 and -2. So it's gonna be around here. Now here I have the point -2 and 4. This is -2 and -4, and this is my -4. So it's like randomly close to this point. So this is the graph of this function. Okay, any question for the graph for the first part? Any question for the first part? Now for the second one. What is the slope of the graph of f? For slope, I need two things. I need 2 points. I can get these 2 points from the graph. So I can choose any 2 points from the graph. Okay, what point would you like to use? This is easy point, so I'm going to use the 0 and 2, and I'm going to choose another point. So I'm going to use the point, for example, 1 and 5, this point. So I'm going to use this point and this point. The points that I choose are the points is 0, 2, and the second point is 1 and 5 from the graph. This point and this point. Now I'm going to do the slope. What is the slope? Slope, what is the formula for the slope?
y2 minus y1 over x2 minus x1.
Again, y minus what?
y2 minus y1 over x2 minus
Yes,
x1.
this is correct. So the slope is the difference of y over the difference of x. So here in this point, this is my x1, this is my y1, this is my x2, this is my y2. So the difference of y over the difference of x. So 5 minus 2 over 1 minus 0. And what is that equal? Five minus 2 is 3 over 1 minus 0 is 1. 3 over 1 is 3. So the slope of this function is 3. I pick 2 points, then I find the slope by using the formula, the difference of y over the difference of x. Actually, I can find the slope, like to make sure the question when they ask you what is the slope of the graph, you have to choose 2 points from the graph or from the line, and you have to use the formula. But to make sure your answer is correct, just go back to the function here in the up, and you will see the slope is 3. You see the slope is 3. So when your answer is 3 here, and you just to check your answer is correct or not, just go back to the function and check what is the slope from the function. So the slope here is 3, and my answer is 3. So I find the correct slope. Could you leave the slope as a fraction as the final answer? 3 over 1? Yes, you can leave it as 3 over 1, but it's better to write it as 3 because anything over 1 is the same as the numerator. A over 1 is equal A. B over 1 is B. 100 over 1 is 100. Okay, now the third example for this section is slope and rate of change. So how is the slope and the rate of change? What is the relation between the slope and the rate of change in the linear function? So here, slope and rate of change. There is a relation between slope and rate of change. I mean, for the if rate of change is the same as the average rate of change. So what is the relation between the slope and the rate of change? As I said in the beginning of this class, for the linear function. What is the relation between the slope and the average rate of change for the linear function?
The relation is that if the function itself is linear, they will both be constant.
Exactly. If the function is linear, both of them are constant, or both of them are equal. The slope and the average rate of change are equals. So here I can say uh, for the linear function of x equal ax plus b, the slope of the graph of f and the rate of change f are both equal to what? To a. Both of them are equal, and also I can say a is equal the slope of change of f, and this is equal the rate of change of f. For the linear function f of x equal ax plus b, the slope of the graph of f and the rate of change of f are both equal to a, and the coefficient, I mean like a is the coefficient of x, this a, and I should to know a is equal the slope of the graph of f and the same as the rate of change of f. Let me give you example for this. So example, let my function f of x equal 3x plus b plus 6 is a linear function. Number one, sketch a graph of f. Number two, what is the value? What is the slope of the graph? Number three, find the average rate of change, average rate of change of the function f. So my example is, suppose I have a function of x equal 3x plus 6 is a linear function. So the question is, sketch a graph of f without making a table. I don't have to make a table here. And second part, what is the slope of the graph? Third part, find the average rate of change of the function f. So to graph this function without using the table, I should to find the y-intercept and the x-intercept. What is the x-intercept for this function? What is the x-intercept? Set y equal what?
0.
0. Then you have to solve it for x. Then solve for x. Okay, who will do this one? Who this one? When you set y equals 0 and solve it for x. Okay, I'm going to do it. So you make, yeah, go ahead. Fill out.
You just plug in 0 for y.
Okay. So 0 equal what? 3x
Y, yeah.
plus 6. Yeah, okay. You have
plus
to
6,
solve
yeah.
for x. Yeah, what you have to do now?
So you have to subtract 6 on both sides.
Okay, correct. Subtract the 6 from both sides. This cancel out. What I get now?
You get negative 6 equals 3x.
3x. Now what you should to do?
Now you divide 3 on both sides.
Divide 3 for both sides. I get negative 2 equal x. So my x now is equal negative 2. What is the mean of my x is negative 2? So the point here I can say the point is negative 2, comma 0. This is the first point. So actually to graph the function f of x, the linear function, I need 2 points and I have to graph or draw a line between these 2 points. So the first point from the x-intercept is -2 and 0. Now for the second point is the y-intercept. Okay, y-intercept. Okay, who will do the y-intercept? What I should to do? Set what? Yes.
You said x2 equals 0.
Okay, correct. X equals 0. Then you have to solve it for y.
Yeah.
Okay. Can you do it?
So you get f of x equals 3 times 0 plus 6.
Yeah, exactly. 3 times 0 is 0 plus 6. So 3 times 0 plus 6. And now I get f of x what equal?
6.
Equals 6. So my second point now is 0. This is mean the y-intercept. The x is 0 and I mean x equals 0. So the point is 0, comma 6. So actually I get 2 points. The first point is -2 and 0. The second point is 0 and 6. Now I can graph the linear function here for the first part. So my Cartesian plane now look like this. So the first point is 0, -2 and 0. -2. -2, here is -2. So here is -1, -2, and 0. This is the first point. And the second point is 0 and 6. This is -2, comma 0, and 0 and 6. So here I have 2, 4, and 6, 8. Here 2, 4, 6, 8. So my point here is 0 and is 0 and 6. So the point here should be 0, comma 6. Now I have 2 points in the Cartesian plane, just I have to draw a line between these 2 points. So my graph look like this. This is my graph for this function. Is it clear? Then if the question asks to graph without the table, just you have to find the x-intercept and the y-intercept to find 2 points. Then you represent these 2 points in the Cartesian plane and you have to draw a line between these 2 points.
Wait, can you go to the last slide so I can take a quick picture?
Yes, go ahead. So again, sketch a graph. You have to find the x-intercept. You
Okay,
set
thank you.
x, y. You're welcome. You set the y equals 0. Then you solve it for x. You find the first point is -2 and 0. To find the y-intercept, you set x equals 0. Then you solve it for y. So the point is 0 and 6. You get actually 2 points. The first one is -2 and 0, and the second point is 0 and 6. Now you represent these 2 points in the Cartesian plane is -2 and 0 is here, and the second point is 0 and 6 is here. Then you draw a line between these 2 points, and this is the graph of the linear function. This is f of x. Now my second question is, what is the slope of the graph? Like before, I said to find the slope of the graph, you have to get 2 points. Then you have to use the formula, the difference of y over the difference of x. Now I have in this graph two points. The first point is -2 and 0, and the second point is 0 and 6. So I have 2 points. Are -2, 0, and 0, 6. Slope equal the difference of y over the difference of x. So here is x1, y1, x2, y2. Now the difference of y is 6 minus 0 over the difference of x, 0 minus -2. 0 minus -2. And what is the answer now? What's the answer? 6 minus 0 is
6.
6. And 0 minus -2 is
2.
2, positive. 6 over 2 is
3.
3. So the slope here in this example is 3. The third part, find the average rate of change of the function f. So to find the average rate of change of the function f, I need also 2 points. The points are the same like before, -2 and 0 and 0, 6. When you say -2 and 0, this is mean, so here the point -2, 0 is f of -2 equals 0. And the second point, 0, 6, is f of 0. This is mean f of 0 equals 6. Now let's applying the average rate of change formula. Average rate of change equal f of b minus f of a over B minus A. Now, my B is here. This is my B. And this is my A. This point here is my B. And this is my A. So f of 0 minus f of minus 2 over B minus A. What is B? It's 0 minus minus 2. The 0 minus minus 2. Now, what is f of 0? What is f of 0? What is f of 0 in this question? It's 6. Yes, f of 0 is 6. So 6. What is f of minus 2?
0.
Is 0. So here 6 minus 0 over 0 minus minus 2. What is 0 minus minus 2? Is 2. And now I get 6 over 2. 6 over 2 is 3. So look, the average rate of change is 3 and the slope is 3. What does that mean? This is mean the slope and the average rate of change are the same for the linear function. Okay, here for the linear function, the slope and the average rate of change are similar or are the same or equal. Any question for this example? Any question? The last things in this exam, in this section, is the model. How we can connect the linear function with our real life. So here making and using linear model. Making and using the model. So for this one, I'm going to give example. It's a direct example. And by the example, I'm going to explain how we can connect the model with our real life. Okay, who will read this example?
Water
Who will
is
read this
being,
example?
oh yeah, I'll read it.
Yeah.
Water is being pumped into a swimming pool at the rate of 5 gallons per minute. Initially, the pool contains 200 gallons of water. Find a linear function v that models the volume of water in the pool at any time t. If the pool has a capacity of
Okay.
600 gallons, how long does it take to completely fill the pool?
Thank you so much. So I have a water is being pumped into a swimming pool. So this water pumping inside the water, the pool, like as a rate of 5 gallons per minute. Every minute, we get inside the pool 5 gallon. So, and also I have initially the pool contains 200 gallon of water. So the question is find a linear function. This linear function is written as by using the v, by using the function v that models the volume of water in the pool at any time. Okay, so here they give me inside the example the rate of change, the rate. So first of all, I have to write the linear function. So I know the formula for the linear function. The linear function has a formula v of t equal what? A times this variable plus b. Now, what is the value for A and what is the value for B? My question now, what's the value for A and what is the value for B? Zainab said V of t equal 5t plus 200. Okay, so Zainab, she said the A is the rate, is the 5 gallon per minute. And she said the initial value, this is correct, the initial value is 200 gallon of water. So actually, this is the y-intercept. The y-intercept means at the time equals 0, what is the value? This is mean the initial value. So the b is the initially contains what? And the value a is the rate. So the rate for the example is 5 gallon per minute. So here can I say the a equal 5. Also, I can say the b is equal 200. So for the first example, v of t is equal 5t plus 200. Any question? Is it clear what you said here, what I did? Is it clear how we can find the linear function? Now for the second one, who will do the second one?
I can do it.
Okay, go ahead.
Okay, so the pool's capacity is 600 gallons, so that's gonna be the V of t.
Okay.
600 equals 5t plus 200.
Okay.
And then
And the question asked about what?
time, yeah. How long?
For t, right?
Yeah.
They ask for t, right? Okay.
So we're solving for t.
So 600. So let me write what you said. V of t equal 5t plus plus what? Plus 200. Okay. What is V of t?
600.
600 equal
5
5t
plus 200.
Okay. What I should to do now?
Subtract 200 on both sides.
Okay.
Then you're gonna get 400.
400 equal what?
5t.
5t. Then,
And then you divide by 5 on both sides.
okay. And what is the value for t?
It's gonna be 1 minute and 20 seconds.
Why 400 divided by 5 is?
Is 80? Oh, wait, 80 minutes. Never mind.
80 minutes is not 8. Okay. 80 minutes.
1 hour
It's like 1 hour and what?
and 20 minutes.
20 minutes. Correct. 1 hour and 20 minutes.
That's the time it takes to fill up the pool completely.
Exactly. And 20 minutes. Thank you. This is correct. Just you have to plug inside v of t the 600 and you have to find the value for t. So t is 80 minutes, 1 hour and 20 minutes. Any question? Okay, so no questions. Now let's go to the next section is 2.6. How we can now we're going to learn how we can graph any function without using table by using the transformation. Okay. So we're going to use some rules to learn how we can graph any function. So 2.6 transformations of functions. Okay, so first of all, before I start this section, I'm going to graph some important function. I was talking about this function in the previous sections, but let me remind you how we can graph this function. So first of all, I'm going to start to graph the function f of x equal x. So the graph of function of this form, it must be something like this. It's look like a line like this. This is the graph of the function f of x equal x. When you see something like this, f of x equal x, you should to know is a linear function. The graph of this function is line like this. Second part of the function you have to know is the parabola. So like function of the form number 2, f of x equal, for example, x squared. How is the graph for this function? Anyone can remind me?
It would be a parabola.
Exactly, parabola. It's look like a cup. So the graph of this function is parabola like this. Always, the graph of this function is a parabola of this form. And also, this is called a power function. Also, we learn how to graph the function of the form like 3. Here, number 3. F of x equal x cubed, like this. So the graph of this function is look like this. So the graph for this function is like this. This is the graph of f of x equal x cubed. Okay, now for the graph for the other functions, like the square root of x. So if the question is graph the function f of x equal the square root of x, the graph for this function, as we talked about this before, this function has a domain is only the positive real numbers. I cannot plug any negative numbers inside this function. So the function should be graphed like this. And we learn how to graph this function by using the plotting point. Number 5. Also, we should to know how to graph the function f of x equal the third root of x. Third root of x, I can plug negative and positive inside the function. So the function should be something like that. Like this. This side is supposed to be something like this. Okay, number 6. Number 6. We should to know also the graph of the function, the absolute value f of x equal the absolute value for x of x. So the graph of this function is look like here. So for this function here, the graph is look like double line. The first one goes like this. And the second line like this. This is the graph of the absolute value for x. And also we should to know how to graph the function f of x equal 1 over x. So f of x can I move to the next slide? Okay, so f of x equal 1 over x. So the graph of this function so I can plug inside this function all numbers except the 0. I can't plug 0. So the function should be like this. Is it close to the y, close to the x? And in this side, it's close to the negative y and close to the negative x. Like this. Okay, for the function f of x, equal 1 over x squared. So the graph of this function also, it should be like here. Is something like that. And in this side, I can plug the 0 also, but it will give me a positive like this. So we'll be close to the 0. Okay, so these functions, we should to know how to graph the initial graph for them because we're going to use it during this section. Here number 7, here number 8. We should to focus exactly more for the parabola, for the quadratic, for the square root, for the third root, and for the absolute value. Also, this is we have to focus like we should to focus for the first 6 more than the first 6 graph more than 7 and 8. But 7 maybe we can get some questions and also 8. So first of all, we have to learn how we can do vertical and horizontal shifting without using the plotting point. So the rules like this. Here, vertical and horizontal shifting. Vertical and horizontal shifting. So first of all, we have to suppose I have a value C, any number, this C is greater than 0. Any constant. Yeah, can you go back here? Okay. So suppose I have, I'm going to start for the vertical and horizontal shifting. So suppose I have like a value C. This C is a positive number. Now I have some rules. The first one say the graph, if I want to graph the function y equal f of x, for example, plus C. I want to add like any random number to the function f of x, and I need to graph the function y. So the graph of this function is actually depending in the graph of the function f of x only. So, but we have to do shifting for the function f of x by shift it up by the C unit upward to the up. So shift to graph this function, I mean, we have to shift the graph y, shift the graph of y equal f of x upward C units. So we have to graph the function again, y equal f of x plus C. Just we graph the function y equal f of x. Then we have to shift this function C units upward to the up. The same things if I want to do shifting downward. So the graph of the function y equal number 2 to the graph to the function y equal f of x minus now. If I want to subtract the C, the number from this function, to graph this function, we should to graph the function y equal f of x, then we have to shift it downward C unit. C units. This is for up and down, for vertical shifting, up and down. So here, for the vertical shifting. This for the vertical shift. Here, can say vertical shifting. Any question for the vertical shifting? Is it clear? If the question asks me to graph the function f of x plus c, and I know how to graph the function f of x, just you have to graph the function f of x, and then you have to shift it c unit upward. If the question asks me to graph the function y equal f of x minus c, minus number, this c is here, is a positive number, then I have to graph the function f of x, then I have to shift it downward c units. I mean, the function f of x is a function of this, is look like x, like this, the first one, second one, third one, fourth one, fifth one, sixth one, or the seventh one or eighth one. So we have to graph one of this, then we have to shift it, depending in the value of c. Now we're going to do shifting horizontally. This is this shift here is a vertical. Okay, for the horizontal one, it's the same things, but the C, the position of C here should be inside the parentheses. So here inside the parentheses, so to graph the function f of x, y equal f of x plus c, we have to shift the graph of y equal f of x to the left C units, I mean, here number 4. 3, and this is 4. Again, the graph of y equal f of x plus minus c, but the minus is inside the parentheses. We should to graph the function y equal f of x, then we have to shift it to the right, c units. So this is like horizontal shifting. Here, horizontal shifting. Horizontal shifting. Okay, is it clear, this one, the blue one and the red one? I'm going to explain it more by like graphing. So suppose I have the graph. The question is, suppose I have the graph of the function f of x like this. So my function f of x is something like this. This is the function f of x without doing any shifting. This is f of x. And I need to graph the function f of x plus 5, plus 6, or any c unit, c number, I mean. So if I need to graph the function f of x plus 5, I have to shift this function upward c unit. So it depending in the value of c. So it's going to be something like this. This is mean here we shift the original function f of x c unit upward. Like this. All the points are shifted upward c units. So this function is f of x plus c. Now to graph the function f of x minus c, what we have to do? How we can graph the function f of x minus c? How we can graph this function? What we should to do?
Move it 1 point down.
Yes, we have to move the function, the original function f of x, the black one, c unit down. So the graph will be something like this. So this is like c unit down. So like this, downward. This is f of x minus c. F of x minus c. Look, the c and here the c is outside the parentheses. Now for the second one, to graph the function horizontally, this is vertically, up and down. Now horizontally, so here is the graph. This is the Cartesian plane here. And suppose my function is something like this. And I need to graph the function f of x plus c inside the parentheses. I need to graph the function f of x plus c, and the c, it's inside the parentheses like this. So when the plus c, we have to shift the original function f of x, this one, left c units. We should graph the original function c units to the left. So this is my f of x. I need to shift this one c unit to the left. What does that mean of the left? How can like shift it to the left? I mean, like this. all points go to the left, like this. Like this. All points goes to the left. So this is the graph of this function. So the function is f of x plus c. Now, how can I graph the function f of x minus c? And the c is inside.
You have to shift it to the right, the graph. C
Exactly,
units.
exactly. We have to shift the function, the graph. I have the f of x, I have to shift it to the right. It depends in the c. Like if it's 5, we have to shift it 5 units. If it's 6, we have to shift it 6 units, depending in the value of c. So, but actually, I'm going to see it's c is a random value. So it's suppose we have to shift the black curve to the right c units, like this. And this is my graph for f of x, here f of x minus c, minus c. Okay, any question for this one, for the first graph and the second graph? Any questions? Okay, we're going to stop up to here today, and I will see you Wednesday. Have a good day, everyone.
I have a question.
Yes,
So for the homework, did you say that it counts towards the grade or it doesn't?
we're not going to count the grade for the homeworks.
Oh, okay. But they just help for the tests and stuff?
Just the tests.
Okay. Thank you. Have a good day.
Have a good day.